Hello guys, today I'm telling about the presentation topic is about digital electronics, memory and the PLD fundamentals. There are five people in our group, Bharat Chaudhary, Sudhir, Jayteja, Hashit Prasad and Venkat Bharat. The main motto the main motto of our PPT is about the how memory and the PLD fundamentals are used in the nowadays on the digital electronics.
Hello sir, I'm Harshit. Now I'm going to explain Unit 5 overview, a journey into digital systems. They are classified into four types. They are classification of memories, RAM fundamentals, programmable logical devices, combinational logical implementation. First one, classification of memories. Delving into ROM types. They are ROM, PROM, EPROM, EEPROM, EAPROM, along with their organization. The second one, RAM fundamentals. RAM fundament exploration of RAM organization, understanding the write and read operations. Third one, prog- programmable logical devices, PLDS. Introduction to PLAS and PALS and FPGAs and their distinct architectures. Fourth one, combinational logic implementation. Practical applications like implementation of logic circuits using ROM, PLA, and PAL. Now I'm going to explain ROM, read-only memory, unchanging storage. ROM is a type of non-volatile memory, meaning data stored within it persists even without power. It, it's primarily used for storing firmware and boot up instructions and constant data that rarely, if ever, changes. ROM organization typically typically structured as decoder driving array of OR gate, where specific connections are programmed to present stored data. Thank you.
In this PPT, I'm telling you about the RAM. There are three types of operations we are using. RAM operation, write operation, and the read operation. RAM operation. RAM is typically arranged in a matrix of storage class. These cells are accessed using row column decoders to pinpoint specific location. Write operation. To write data on memory, the data is placed into the data lines. Simultaneously, the address line select the specific memory location where the data will be stored. Read operation. To read the data from the memory, the address line set the desired memory location. The data currently stored in that location is then retrieved and outputted on the data lines. Diagram explanation gives bottom left. Address the specific location code or sent to the RAM. RAM, the hardware process the request. Data, the information is effectively stored and retrieved.
Programmable logic devices (PLDs) are special electronic chips that can use program to be different logic tasks. Instead of building circuit from scratch with individual logic gates, you can change what the just by programming it. This makes PLDs flexible and useful for many types of digital electronics. Main type of PLDs PLA programmable logic array. Both part of the chip, the end part and the R part, can be programmed. This gives a lot of flexible and let you create complex logic. PAL programmable logic array. The end part is programmable, but the R part is flexible. This makes it simple and cheaper. Good for basic logic design. FPGA Field Programmable Gate Array, the most powerful and flexible type, made of many small logic blocks you can configure however you want, has programmable inputs, outputs, and connections. Thank you.
Now coming to the next slide. This slide explains ROM can be used to implement combination logic circuits. Normally, we think ROM is the only for storing data, but here ROM acts like a logic device. This idea is small, but the input variables work like address lines. and each address represents one combination of inputs. Whatever output we need for that particular input, we store it in the ROM location. In the way, the truth table of the logic circuit is stored inside the ROM. We When we give our inputs, ROM reads and corresponding address and gives the output immediately. Because of this, ROM can implement any combinational logic function without any additional logic gates. This makes ROM a very flexible and powerful component for digital design. Now, coming to the next slide, we look at the logic implementation using PLA and PAL. First, we have PLA, Programmable Logic Array. PLA is highly flexible because both and OR arrays are programmable. We can design multiple logic functions and even share product terms between outputs. So, PLA is perfect for implementing complex Boolean expressions or multiple outputs. Then we have PAL, Programmable Array Logic. PAL is simpler. It has a programmable and array, but a fixed or array. This makes PAL faster and cheaper than PLA, but slightly less flexible. PAL is mostly used when the logic is straightforward and doesn't need too much customization. So the summary is PAL gives more flexibility. PAL gives better speed and simplicity. PLA gives more flexibility. Both of these devices help in implementing digital logic without using too many gates, make design efficient and compact.
Hello guys, this is Bharat Chaudhary from Section G. This is conclusion of this presentation. Memory plays a central role in digital systems, acting as the backbone of digital data storage and retrieval. By understanding the classification of memory, we see how ROM provides permanent data storage while RAM supports temporary read-write operation essential for program execution. Programmable logic devices such as PROM, PLA, and PAL allows flexible implementation and combinational circuits, makes digital design more efficient and customizable. Together, these memory elements and PLDS from an essential foundation from building reliable and high performance digital systems. Thank you.